Graphing rational functions. Just recall, we've talked about asymptotes before. It's the line the graph approaches but doesn't touch or cross over. So we're going to graph each of the following rational functions. So for this first one, we have 6 divided by x. So if we plug in -3, 6 divided by -3 gives us -2. 6 divided by -2 gives us -3. This would be -6. If I plug in 0, remember I can't divide by 0, so this would give me an error. So again, we can't divide by 0. And then this would give me 6, and then this would give me 3 and 2. So if we are graphing this, we have the point -3, -2, -2, -3, -1, -6. And on this side we have 1, 6, 2, 3, and 3, 2. Now for this graph, since we can't divide by 0, that means we are never going to be able to get 0 on our graph. So that's a place that we have an asymptote. So we can go ahead and graph our asymptote. So x cannot be 0. And if you think about it, so if we can't have x as 0, it's going to be really difficult to get 0 out for this equation because the numerator is 6. So we actually also have an asymptote here, a horizontal asymptote. So you have two asymptotes for this graph, vertical and horizontal. So this is the vertical asymptote. So I'm going to abbreviate VA, so vertical asymptote at x equals 0. And this is a horizontal asymptote, HA, at y equals 0. And so that means my graph just follows along the asymptotes without touching or crossing over. And will look something like this. So the horizontal asymptotes tell the end behavior of your graph because notice that as x gets very large in the positive or negative direction, that's what your graph is approaching in the long run for very large values of x. You could even check on your graphing calculator to see what this looks like. So if I zoom in on a standard window, this would give us our graph of y equals 6 over x. So the domain of this graph is all real numbers but 0 because we can't plug 0 in for x. So -infinity to 0, union 0 to infinity. You can write the union symbol if you want. I won't mark off if you don't though. And then the range would also be -infinity to 0, union 0 to infinity. So what would change the vertical asymptote? Well, that would be whatever makes the denominator 0, right? So whatever makes the denominator 0, that would change this vertical asymptote. And what would change the horizontal asymptote would be moving it up or down. So how do you move something up or down? Well, you add or subtract values to the fraction. So if I added +6 or something, that would move my asymptote up 6. And we'll talk about that more in just a minute. So go ahead and compare y equals -6 over x to the graph that we just did using your calculator. We're also just going to go ahead and graph it without our calculator first because we don't want to use our calculator if we don't need to. So -3, when I plug it in, I have -6 divided by -3 now. So that is 2. -6 divided by -2 is 3. This would give me 6. Again, error. And then the next one we have, it would be 6, 3, and 2. So now we have -3 and 2, -2, 3, and -1, 6. And then over here, now we have 1. Oops, I forgot the negatives there. Sorry, I forgot the negative through 6, -3, -2. So 1, -6, 2, -3, and 3, -2. And again, we have an error at that value of 0, so we can graph our vertical asymptote, and again, I can't get 0 out for my horizontal asymptote. And then I graph the branches, which follows the asymptotes but doesn't touch or cross over. So you want to graph them as close to the asymptotes as you can. So now you notice that these graphs essentially look very similar. The only difference is that they're in different quadrants. So it kind of looks like a reflection across the x-axis. So our domain is still the same, negative infinity to 0, union 0 to infinity. And the range, same thing. And we still have a vertical asymptote at x equals 0 and horizontal asymptote at y equals 0. It's very important when you're writing your asymptotes that you write x equals or y equals, because notice they're aligned, so you don't want to forget putting that down. So those are the basic rational function graphs. Let's go ahead and look at translations of rational functions. The graph of y equals a over x minus h plus k is a translation of y equals a over x by h units horizontally and k units vertically. So just like we have y equals mx plus b, we also did last year our quadratic equations. Remember, we had a times quantity x minus h squared plus k, and then we did our absolute value functions this year. So it's kind of the same idea with the h and the k. So your vertical asymptote comes from the denominator. You set it equal to 0 and solve. So then you would get, in this case, x minus h equals 0. So that means that x would be equal to h. The horizontal asymptote y equals k comes from the number on the outside of the fraction. So this is the number on the outside, so that means we're going to move our asymptote up or down. These are the steps for graphing. Find the asymptote and graph. Make a table choosing a point to the left or right of the vertical asymptote, and then draw the branches. Remember, we're not going to use our calculator. You can use your calculator when you're done to check your work, but as you're doing them, do not use your calculator. So let's go ahead and sketch a graph of y equals 1 over x minus 2 minus 3. So the first thing you want to do is find the asymptotes. So we know that whatever is in the denominator cannot be equal to 0. So x minus 2 set it equal to 0 and solve, and we get x equals 2. So that means we know we have a vertical asymptote at x equals 2. This number tells us our horizontal asymptote is y equals negative 3. So that means we're moving our graph down 3. And this one moves to the right 2. If we think about our transformations, remember that when you have the x, it's opposite thinking. So let's go ahead and do our asymptotes. We have x equals 2, and then y equals negative 3. Make sure you're using a ruler when you graph your asymptotes so they're straight lines. And then we can go ahead and start to graph. So how do you know which side of the vertical asymptote? Because you always have to pick one, or the left and right side, because if you have the left side, then it's either in one of these two regions, and the right side is one of these two. So you're just going to pick points to the left and the right of the vertical asymptotes. We're going to pick 2. So if this is at x equals 2, then to the right of 2 would be 3 and 4. And we know that 2 is the error. To the left of 2 would be 1 and 0. And actually, let's just go ahead and put that in order. So I'll do 4, 3, 2, 1, 0. So when I plug in 4 into my equation here, I get 1 over 4 minus 2 minus 3. So 4 minus 2 is 2. So 1/2 minus 3 gives me negative 2.5. If I plug in 3 into my equation instead of the 4, I get 1 over 3 minus 2, which is 1 over 1. So 1 minus 3 gives me negative 2. If I plug 1 into the equation for x, I would get Here, 1 minus 1 gives me negative 1, so this is negative 1 minus 3, which is negative 4. And if I plug in 0, I get negative 1 half minus 3, which gives us negative 3 halves. So on my graph, I have the point 1, negative 1, 2, 3, 4. So now I know it's going to be in this lower region because we're not supposed to cross over these asymptotes, so I don't really need to plot the other points, but I'm going to since I already have it. So we have 0, negative 3 halves, and then you follow your asymptotes. And same thing over here. So I have the point 3 and negative 2, and 4, negative 2.5. And then we follow our asymptotes. So this was at y equals negative 3. And the domain of this then would be negative infinity to 2 union 2 to infinity, all real numbers but the asymptote at 2. And the range is all real numbers but negative 3. So negative infinity to negative 3, negative 3 to infinity. So that's it for this graph. Go ahead and do the next one on your own. And when you're finished, we'll go ahead and check the work. So go ahead and pause it. Looking at this graph here, so a couple different things to notice. I notice right away we have the negative here. So make sure that you include that when you do your graph, because sometimes students miss that. So then x plus 7 equals 0, so x equals negative 7. And this is the horizontal asymptote at y equals negative 3 again, just like the last graph. So y equals negative 3 and x equals negative 7. So we already know what our domain and range are going to be because of that, but let's go ahead and graph it to figure out where our graph's going to go. So we know at negative 7 we have the error because that's where my vertical asymptote is. So we're going to pick points to the left and to the right. So let's just go ahead and do 1 point now because we only really need to know which region we're in. Are we in the upper region, the lower region, or same thing on the right side? So let's do to the left of negative 7 would be negative 8, to the right would be negative 6. So if I plug negative 8 into this, I have negative over 1 over negative 8 plus 7 minus 3. So negative 8 plus 7 is negative 1, so that gives me negative 1. So negative 1 is positive 1, minus 3, which gives me negative 2. And if I plug in negative 6 here, that gives me 1. So 1 over 1 is just 1. We have the negative in front, so negative 1 minus 3 is negative 4. So over here we have negative 8, negative 2. So that tells me that is the graph is in this upper region following the asymptotes. And over here to the right, we have negative 6, negative 4. So that means we're in the lower region. We will do rational functions that don't always have them in catty corner regions. They'll sometimes be next to each other, but we'll talk about that tomorrow. So for this, we have the domain negative infinity to negative 7 and negative 7 to infinity. And the range is negative infinity to negative 3, negative 3 to infinity. Now, if you did want to check this on your calculator, like I said, we're going to be graphing this without our calculator, but we can check it using our graphing calculator. Just be careful of how you plug it in. So I have negative 1 divided by, make sure you use parentheses for your denominator, otherwise your calculator is going to think you're doing something else. So x plus 7, so make sure you close that parenthesis, and then the minus 3 would be on the outside. So if we look at our graph, you can see our graph looks like the one we just did. And if we go to our table, we can check our vertical asymptote because it should say error at -7. And we can check the other points that we have too, -8, -2, -6, and -4. And so that means you can see in the long run, as x gets very large in the positive direction, your y values are approaching the horizontal asymptote, which is at -3. Same thing in the negative direction. So you could write the end behavior like we did in the last section. So you could say, for this end behavior, you would write as x approaches infinity, your y values approach -3, and as x approaches -infinity, the y values still approach -3. So this is the end behavior. Just like when we talked about end behavior with polynomial functions. Looking at number 5, it says write an equation for the translation of y equals 5 over x that has asymptotes at x equals -2 and y equals 3. So we know this is the number on the outside, and we know this helps us determine our what's in our denominator. So if I make this equal to 0, that's going to tell me what I'm going to be putting underneath here. So to make this equal to 0, I'm going to add the 2. So I get x plus 2. So this would be y equals 5 over x plus 2, and y equals 3, so plus 3. So this is again the vertical asymptote and the horizontal asymptote. So that means that our graph moves left 2 and up 3. So left 2, up 3 for the translations. Looking at the next one, it says write equation the translation of the graph y equals -1 over x that is 4 units left and 5 units up. So 4 units left means that the vertical asymptote is at x equals -4, 5 units up, that means we have y equals 5. So if I set this equal to 0 by adding the 4, I get x plus 4 equals 0. So this would be y equals -1 over x plus 4 plus 5. So take a minute to see if you can do 7 and A and B on your own. Write an equation for the graph below. When you're done, you can unpause it to check your work. Looking at this first one, we would want to figure out where our asymptotes are. So it looks like we have, oops, our vertical asymptote here. So it looks like the vertical asymptote's here. And the horizontal asymptote looks like it's right here, because it should be the line the graph is approaching but does not cross or touch over. So it looks like our vertical asymptote is at x equals, so that's 4, and that's 6, and that's 8, so x equals 6. And our horizontal asymptote is at y equals 4 because it goes 2, 4, 6. So for my equation, I have y equals 1 over x minus 6 plus 4. So for now, we're just going to use 1 for the numerator value, and we'll maybe talk about later how to get that number, but just 1 is fine. Over here, do the same thing with your asymptote. So if you look, it looks like we have a vertical asymptote at x equals, that's -4 here, and -6, so -5. And at y equals, so if this is at 2 and that's at 0, so that would be y equals 1. Now notice that, again, these are in these two quadrants, so that means we're going to use a positive value. If it was in the other two, I would use negative. So y is equal to 1 over x plus 5 plus 1. And that's it.